Hello friends, welcome to Learner's Planet. Friends, in this session of permutation combination, we'll be taking more problems based on letters, numbers and other arrangements. Right? In the previous session, we did good number of problems based on arrangements. So, bit higher difficulty level problems we will be taking in this session. So, let's begin it. Now, let's see this question. The principal wants to arrange 5 students on the platform such that the boy Salim occupies the second position and such that the girl SITA is always adjacent to the girl RITA. How many such arrangements are possible? Right? Now we have 5 students 1, 2, 3, 4, 5. At the second position, the person Salim is fixed, so we just have one choice over here, right? Now for the other positions we need to have SITA and RITA together, right? So we treat them as one person. Now we have fixed one person. Now we are left with 4 places and we have to arrange 4 persons. In that I tied up S and R, that is SITA and RITA, and now I have 2 more persons, right? Maybe P and Q. Now since S and R have to be together, that is SITA and RITA have to be together, none of them can come over here. So these 2 people will take place from these 3 positions, that is consecutive positions, right? Now friends, for 2 consecutive or adjacent position we have 2 options, that is this and this, right? Either this should sit in both these seats or both these, right? That means S and R can be arranged in 2 factorial ways, and there are 2 adjacent choices we have, so into 2 factorial, right? Now the third one is on the third seat P and Q should sit, right? So now S and R have been arranged into 2 factorial ways. Now we are left with 2 positions, and on these 2 positions P and Q can be arranged in 2 factorial ways, right? So 2 into 2 into 2, that is 8 ways are there. Clear? I just repeat it once again. S and R, we just have 2 adjacent positions over here, that is 1 and this 2. So S and R can sit in 2 factorial ways, then S and R can mutually arrange themselves in further 2 factorial ways, that is SR, RS here, or maybe SR, RS here, right? So it's clear to you? Then the remaining for 2 remaining positions P and Q may sit in 2 factorial ways. So in all 8 ways are there, right? Now, how many numbers between 400 and 1000 can be formed with the digits 0, 2, 3, 4, 5, 6 if no digit repeated in the same number? Now friends, numbers are between 400 to 1000. That means obviously 3 digit numbers are there, right? So 1, 2 and 3. Now the numbers should be greater than 400. That means we have the single option that the first position should be occupied by 4, 5 or 6 only, right? So the numbers will be greater than 400, right? Otherwise, if we choose any of these remaining number, that is 0, 2 and 3, then the numbers formed will be less than 400, right? So we have 3 options over here. Now we don't want the repetition, but at the second place we have 1, 2, 3, 4, 5, 6 choices, but we don't want the repetition. So we'll remove one number that has already come over here. So we are left with 5 choices. Now next, 2 numbers have already been there, and now we are left with the 4 numbers. So it's 60 numbers, right? Now let's see this question. Further, various types of arrangements are there. 3 conditions are there. Let's take conditions one by one. Find the number of ways in which 5 boys and 5 girls be seated in a row so that no 2 girls may sit together, right? That means we need to arrange the girls between 2 boys, right? So suppose these are the positions by boys 1, 2, 3, 4. Instead what we do, we take 10 positions. Just a moment. It's 1, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Right? Now the girls don't have to be together. So what we can do? We make them sit alternately. Right? Now the arrangement which I have taken over here is this, and the arrangement from the girls may start from the first position also. So this, this and this also will also be an arrangement, right? So we will be calculating both the arrangements. Now no two girls may sit together, so the girls have to sit on these positions, or alternatively what you can do is we start from this position, right? So we are having 6 places for the girls, right? See, if we start from this, the last position will automatically be vacant, right? So we have 6 positions for the girls, and we have to just make 6 girls sit. So we just choose 5 seats from 6, and 5 places, 5 girls, they can be arranged in 5 factorial ways, and remaining 5 positions the boys can sit in 5 factorial ways, right? So 65 into 5 factorial. Now what 65 is? It's 6 only. So it's 6 into 5 factorial into 5 factorial, or we can say 6 into 5 factorial will be nothing but 6 factorial. So your answer is 6 factorial into 5 factorial. So friends, I hope you are clear. I just repeat it once again. Either since the girls have to sit alternately, we started with the first position and we took them to the last position, right? So we are left with the 6th position for the girls. So they may sit alternately, right? Now the girls are 5, so we need to select 5 places from 6 places, and from 5 places the girl may sit in 5 factorial base, and the remaining 5 places are for boys, so they may sit on 5 factorial ways, right? So in all, this is your answer. Now the next is all the girls sit together and all the boys sit together. Now what we do in this case, G1, G2, G3, G4, B1, B2, B3, B4. We treat them as one and we treat them as one. Now there are two, maybe we can say 2 persons. So 2 persons can be arranged in 2 factorial ways, first of all. Then these 4 girls have to be together, but mutual arrangements are possible. So 4 places, 4 girls, they can be arranged in 4 factorial ways. Similarly, 4 boys, 4 places, mutually they can arrange themselves in 4 factorial ways, right? So this is the answer, right, for the second one. Okay, I'm sorry, there were 5 girls, so it's G5 and this is boy 5. So it will be 5 factorial and 5 factorial, right? But the concept is same, right? Now the next is all the girls are never together, right? First of all, what we do in this case, we make the arrangement when all the girls are together. See, total number of arrangements are what? 5 boys and 5 girls. If there is no condition, the total number of arrangements will be is 10 factorial, right? Now out of these 10 factorial arrangements, we find out the arrangement when all the girls are together, right? So it's 5 girls, G1, G2, G3, G4, G5. We take them as 1, and the remaining 5 positions are for boys. So it's B1, just a moment. So the total arrangements is 10 factorial. Now we take all the girls as 1, G1, G2, G3, G4, G5. I treat them as 1. Then boy 1, boy 2, boy 3, boy 4, boy 5. Now in this case, boys don't have to be together, right? It's not necessary, right? So we have 1, 2, 3, 4, 5, 6 places to arrange 6 persons. So we can arrange them in 6 factorial ways, right? Now these 5 girls mutually arranged in 5 factorial ways, right? So These are the arrangement when all the girls are together, and these are the total number of arrangements. So in the remaining arrangements, that is this, all the girls will never be together, right? See, 2 3 girls may be together, 4 girls may be together, but all the girls will never be together, and we are asked about all the girls are not together, right? So we got the total number of arrangements, that is 10 factorial. Then we deducted the arrangements in which all the girls were together, right? So in the remaining numbers, we will not be getting all the girls together, right? I hope you are clear. Now let's try this problem. How many permutations, or we can say arrangements, of the letter of the word Madhubani do not begin with M but end with I, right? So how many letters are there? It's 1 2 3 4 5 6 7 8 9. 9 letters are there, and this A is repeated for 2 times, right? So let's take 1 2 3 4 5 6 7 8 9, right? Now last position is fixed for I, so we have just one choice over here. Now for the first position, M cannot come, right? So we have how many choices now? Because one already has gone over here, M cannot come, that means we are left with 7 choices. Now out of these 7 choices, we have 2 A's over here, right? So we take 2 cases when the first position is occupied by A, right? So suppose first position is occupied by A, that means we have just one choice. Now 1 2 3 4 5 6 7 places are there, and we have 7 letters and there is no repetition, so 7 factorial arrangements will be there, right? Because in the for the movement inside A and I, only one A is there, so there is no repetition, right? So it's 7 factorial ways will be there. Now the second case is if the first position is not occupied by A, right? That means we are left with the, see, one I has gone, I cannot be there, M cannot be there, 2 A's are not there, so we are left with 5 choices, right? So for the first place, if A is not there, we are having 5 choices, right? Then 1 2 3 4 5 6 7 places are there, and we have 7 letters, so 7 letters can be arranged in 7 factorial ways, right? And for movement between this letter and this letter, we have 2 A's, so we need to divide it by 2 factorial. So in all, 5 into 7 factorial by 2 factorial plus this 7 factorial, right? So if A is at the first place, these will be the number of arrangement. If none of the A is at the first place, then these will be the number of arrangements, right? So we just have to calculate that. It's 7 factorial. We can take it as common. So it's 5 by 2 plus 1, that is 7 by 2. So 7 into 7 factorial by 2 will be our answer. So I hope you are clear with both the cases. Now friends, let's see this question. In how many ways can be the letters of the word intermediate be arranged so that the vowels always occupy even places, right? Now first of all, let's calculate the number of letters in this. It's 1 2 3 4 5 6 7 8 9 10 11 12, right? 12 letters are there. Now next is, what is the repetition? E, 1 2 3 times E. Now then I, 1 and 2 times I. Then T and T 2 times. Now 3 4 5 6 7. Now we are left with N, R, M, A, and D, right? So these 5 letters are for one time, and these letters are for 3 2 and 2 times, right? Now we have to take the first case, the vowels always occupy even places. Now we have vowels, how many vowels? This E, this I, and this A, right? So we have 6 vowels, right? Now we have 12 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Now in these 12 places, vowels should be at even places. So 1, 2, 3, 4, 5, 6 choices we are having, right? And we are having 3 plus 2, 5 and 1, 6 vowels, right? So all the 6 positions will be filled up by 6 vowels, right? Now 6 vowels on the 6 positions can be arranged in 6 factorial ways. Now E is repeated for 3 times, so I would divide by 3 factorial. Then I is repeated for 2 times, so I would divide by 2 factorial. Now this is what the arrangement of just vowels, right? Now the remaining letters, so the remaining 6 letters can be arranged in 6 factorial ways. That is, the consonants can be arranged in 6 factorial ways. And further, T is repeated 2 times. That is a consonant. So further, I would divide by 2 factorial. So these are the total number of ways when all the vowels occupy even places, right? So we just have to solve it. And you can solve it and you'll be getting the answer. So the first problem we have done, right? Now the second one is the relative order of vowel and consonants do not alter. Just a moment. Now the second case is the relative order of vowels and consonants do not alter, right? So what is the order of vowels? That is I, then E, then further E, then I, and then E, and then E, right? So this is the order of vowels, and consonants, it's N, T, R, M, D and T. 3, 3, 6 and 6, 12, right? Now the important point over here, we have to make the arrangement, but the order of vowels and consonant should not change, right? That means the vowel should appear in this manner only. Maybe the consonants are there in between, but the relative order should not be changed. That means E should always come after I, and this I should always come after E, and then A, and then maybe the consonants can come in between, right? So what I do is I just first of all let me arrange the 6 consonants, right? Now 6 consonants can be arranged in 6 factorial ways, but we cannot arrange the consonants over here in 6 factorial ways, because in the 6 factorial ways the order of the consonants will definitely be changed, right? So what is the alternative approach we have? I have 12 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? From these 12 places, I select any 6 places, right? So 12C6, right? So I'm just selecting the 6 places from these 12 places, and on the selected 6 places I have just one way of arranging the consonants, is that the order should be N, T, R, M, D and T, right? So in this order I have to arrange, and that is the single possibility of arrangement. So there is just one way, right? Now on the remaining positions, remaining 6 position, we have to arrange the vowels in this order only. So further 6 positions are there, 6 vowels are there, and there is single arrangement possible. So further it's 1. So in all our answer is 12C6, right? So it's 12 factorial by 6 factorial into 6 factorial. This is the answer. Now friends, it's a change in flavor. Now, if the letters of the word late be permuted or arranged, and the words so formed be arranged as in a dictionary, find the rank of the word late. Now, this is quite different problems from the previous ones, and we have done a good number of problems of arrangement. Now, we just have to find out the rank of a word late while we arrange all the words as in a dictionary, right? So, if we find according to dictionary, there are 4 letters according to dictionary. At the first place, first of all, A will come. All the words from A will come, then from E, and then L, and then T, right? Okay, so first of all what we do is we just find out the total number of words when A is at the first place. So now if A is at the first place, we are left with the three places, and three letters can be arranged in 3 factorial ways, right? So how many how many words will be there that which are beginning with A? That is 3 factorial, that is 6. Similarly, if E is at the first place, the remaining 3 places can be filled up as 3 factorial ways. So this is 6, this is 6, right? Now it comes that word letter L, right? So now we have to find out the rank of late only. So just forget this T. Now L, if L is at the first place, now what happens in the dictionary? What will be there in the second place? From A, T and E, it will be A, right? Then in dictionary from T and E will come, then T will come, right? After that, the next word is L, A, T and E, right? So this is 6 and 6, 12, this is 13 and this is 14th, right? So if you arrange all the words formed by word late in dictionary order, so LATE, that is late itself, will come at 14th place, right? I hope you are clear. Now friends, similar problem. If the letters of the word mother are written in all possible orders and these words are written out as in a dictionary, find the rank of the word mother, right? So first of all, let's find out what is the dictionary order. From these, first of all, we have to calculate the words from E, then H, then M, and then remaining, but we are interested till here only, right? So first of all, let's find how many words will begin from E, right? So we have 6 letters, and E, the first letter is E and the remaining letters are 5. So 5 letters at the 5 places can be arranged in 5 factorial ways. Now from H further 5 factorial words will be formed. So it's 5 factorial and 5 factorial, 120 and 120. Now 240 is done, right? Now let's calculate the words from M, right? Now we have to find out the rank of word mother. Now if in dictionary, if the first letter is M, so according to dictionary, now the second letter will be E, right? So first of all, let's eliminate all the words from M and E, where M is the first place and E is the second place, because we want M and O order, right? So from M and E, the remaining 4 positions can be filled up by 4 factorial ways, right? In all 6 letters are there. 2 are fixed at the first position, M is there, and at the second position E is there. So the remaining 4 letters can be filled up by 4 factorial ways. So more 24 over there. Now after ME, the next turn is of MH, right? So further, just take out all the words from M and H, further 4 factorial. So it's 24. Now the next turn is of O now. Now if the first 2 letters are M and O, and in the dictionary the next letter will be E, right? So let us discard just take out the words where the third letter is E, and that means the first 3 letters are M, O and E. So we are 3 positions and 3 letters can be arranged in 3 factorial ways. So further 6. Now the next is M, O, R, right? M, O, H, sorry. M, O, H. So further 3 factorial. So further 6. Then next is M, O, R. Further 6, 3 factorial. Now next turn is M, O, T according to dictionary. Then after M, O, T in the dictionary, the next set of letters will be E, then H and then R, right? After it, it's one more over here. After it, M, O, T, H, E and R, right? So this is what the mother. So we got 240, that is 120, 120, 240, then 24, 24, these two 24, then 6, this is 6, then this 6, then this 6, and further 1 and 1, right? So we have to calculate all these. I'm sorry friends, here I just forgot, here it is EHR, then here it will be E will be there and ERH will be there, right? ERH. Then MOTHER, right? So it's one more over there. So in all 240 plus 48, that is 288, and this 18, 1, 2, 3, so that is 309, right? So the rank of the word mother will be 309, right? I hope you are clear. I calculated all the words from E, then I calculated all the words from H, right? Then it comes the chance of M. So I calculated the word from M and E because in dictionary E comes before the other letters, right? So from ME, the 24 words are there. From MH, 24 words are there. Now MO, it comes the turn of MO. Then we discarded the words from MOE. So these are 6 words. Then MOH for the 6 words. Then MOR for the 6 words. Then it comes MOT, right? So in dictionary, after T, from E, H, and R, the first letter will be E, then H, then R. Then for the E, R, and H, right? After that, MOTHER, right? So this is 240 plus 48, that is 288, 288, and this 2 is 290, 290 and 18 is 308, and this one is 309, right? These two one I have calculated over here, right? So 309 rank will be there, right? Friends, we have done good number of problems in this session. We'll be taking more problems on permutation and combination in our next session. Now we'll change some flavor of the problems. So let's see what happens in the next session. Bye bye.